Hi everyone, my name is Imani Wilson, and in this presentation, we're going to take some time to explore the communication of neurons through electrical signals called graded potentials. Graded potentials are the first step in how our nervous system helps us feel and react to the world around us. So by the end of this video, you will be able to explain the role of graded potentials in the communication of the nervous system, understand and explain the difference between hyperpolarizing and depolarizing graded potentials, comparing and contrasting the different types of gated ion channels, and identify their locations. Explain the initiation of local potential in the peripheral nervous system compared to that of the central nervous system, using the gated ion channels. And lastly, the ability to analyze what occurs when a gated channel is disrupted. So over here on the right, I have a few really important and key terms that's going to really help us and get us through this lecture. Extremely crucial to the integrity of the information that we have here. You listening and watching this video is proof that our neurons are already hard at work because our nervous system is constantly receiving information. And so here's an example. The fact that you can feel the chair that you're sitting in or on, feel the keyboard as you're typing on your computer or your laptop, just goes to show our body's ability to convert electrical signals into sensations that we can feel. And so these small changes in voltage are what we call potentials. And so depending on how strong the stimulus is, the further that information travels. So for example, when dust particles fall on us, or if there was a very tiny ant crawling on us, the chances of us would be feeling it would be slim to none. However, if there was a tarantula crawling on us and it started to rain, we would most certainly be able to feel that because it's a stronger stimulus and that we can feel. And so our nervous system does a great job at some sort of filtration process of sorts to assist our neurons in deciding which signals matter or are important. And so this is the start of this process, is the graded potentials, which are small local changes in the membrane. So if we can recall from our previous lecture, when a neuron is inactive or at rest, this is referred to as the resting membrane potential, which is at negative 70 millivolts. The role of the local graded potential is when a stimulus like pressure or chemical acts on a neuron, it may cause the voltage to shift either up or down. As you can see in this chart here, we have the resting potential. We have what it looks like when it elevates, and then we have when it decreases. Here, this will be talked about in another lecture in regards to the action potential and the threshold. But the stronger the stimulus, the larger and further the change. So this typically happens right in the dendrites and the body of the cell. And so the dendrites are listed here, and then the cell body is listed here. And so what's important is that here, the effects are limited and they fade away the further it gets from the source of the stimulus. Graded potentials play a key role in triggering what we call the action potential, which will be covered in another lecture. It does transfer information, the graded potentials transfer information, which we refer to as synaptic input in neurons. So there are two types of graded potentials, depolarizing and hyperpolarizing. And so a hyperpolarizing potential makes the inside of the cell less negative and it becomes closer to zero. As you can see here, we have two charts here. Both are a representation of what it looks like for a cell to be depolarized versus hyperpolarized. And so where a cell is depolarized, it moves closer to zero, so it gets higher and really important because we refer to this great change, or the momentum and direction of change is excitatory. So it moves closer to zero. For example, when a sodium ion flows into the cell, the inside of the cell becomes more positive. And so for hyperpolarizing potential, it does the opposite. It makes the inside more negative and it moves further away from this threshold here. So it goes further down. And so this also can be an example of, let's say, potassium when it leaves the cell, or chloride when it enters it. And so you can think of it more like, so you can think of it as moving away from a fire, or moving away. And so we just want you to remember as well that graded potentials are proportional, and so stronger. The stronger the pressure, the stronger the stimulus, the greater. And so the bigger the potential. And so here we have a picture of the gated ion channels. And so gated ion channels are passageways through the plasma membrane that either open or close to regulate the passage of substances. So the first one that you see here is a leakage channel. It is always open and it remains open. And so we also have a graded channel, which opens when a chemical like a neurotransmitter binds to it. And so these are found on the dendrites and the cell body. Then we have the voltage gated channels, which open when the membrane voltage itself changes. And so typically they're located along the axon. And then we have a mechanical gated channels, which means they open when the membrane is stretched or deformed. So you can think of this as like your touch and hearing receptors. And so the combination of which gates open and where determines how the neuron reacts. And just as a reminder, we know that leaky channels are always open. Just wanted to go ahead and reinforce that. So in this section, we really want to go ahead and compare where graded potentials begin amongst the two major parts of the nervous system, which are both the peripheral nervous system and the central nervous system. And so within the peripheral nervous system, the graded potentials start at the sensory receptors. So for example, these are going to be your mechanical gated channels in your skin that respond to either touch or pressure. Now, without even moving to the central nervous system, these graded potentials usually begin at the synapses, where neurotransmitters from one neuron binds to another neuron's dendrites, opening the ligand-gated channels. So while both trigger the local potentials, the type of gated channel it stimulates differs between the peripheral nervous system and the central nervous system. And so right here we have some really important terms. The synapse is going to be the structure in the nervous system in which a neuron transmits a signal to another cell, whereas a neurotransmitter is a chemical that is released by another neuron. Okay, so now we're going to go ahead and dive into how graded potentials kind of like fit into like the bigger picture of communication. First, it's really important that we refresh our memories on what a threshold is. And so that's a point of change in potential which triggers a certain event to occur, such as an action potential. And so as you can see here, we have a chart just going to go over again, highlighting where and at what levels depolarization happens versus hyperpolarization, and where that is in relation to the threshold. And so with that being said, if enough depolarizing graded potentials occur close together, either in time or space, they can add up, or another word for that is summate, bringing the neuron to threshold value. And so the threshold is in the point where voltage gated channels in the axon will open, which will be the start of an action potential. So if a threshold isn't reached, meaning if the stimulus is not strong enough to create a greater depolarizing graded potential, it will eventually close, and there will not be any signal that travels through. But remember, your focus today kind of stops here. The actual firing or action potential is what your classmate will cover next. Okay, so now that we kind of covered the process in which gated channels form and where they reside, I think it makes sense for us just to go ahead and go over kind of what happens when the gated channel is disrupted. And so here you have a chart which has the 4 different types of ion channels and kind of what they look like when they're opened and when they're closed. And so all of this depends on gated channels working properly. So the communication of our neurons, whether they get to graded potentials and then action potentials, all depends on if these gates are channeling and working properly. Any malfunction can truly affect the neuron signaling. And so if leak channels or pumps fail, the resting potential can't stay stable, and so if ligand or mechanical gated channels malfunction, graded potentials may not form at all. If graded potentials don't form at all, there's no chance of action potentials forming. And so from there, there would be we wouldn't be able to feel, touch, things of that nature. And so, and if voltage gated sodium or potassium channels fail, the neuron can't produce or control action potentials correctly. So some disorders called channelopathies come from these issues. For example, sodium channel defects that lead to seizures or muscle weaknesses. And so here we have a practice quiz, just wanting to, completely optional, of course. You can always go ahead and test, kind of how much you understood and like where you are with the information. And so one of the first questions I thought would be a good question is, which type of graded potential moves the membrane closer to the threshold? And if you guessed depolarizing, you are correct. The next question is, which type of gated channel opens when a neurotransmitter binds? If you guessed ligand gated, you are correct. In which part of the nervous system do graded potentials usually begin at sensory receptors? And if you guessed the peripheral nervous system, you are also correct. So just to sum up kind of what we went over here today, graded potentials, they're small vocal voltage changes that occur in the dendrites and the soma. Depolarizing, we refer to that as excitatory. So you can think of this as turning the light switch on, the cell is excited and headed to the action potential party. Super excited, can't wait to have fun. The hyperpolarization or inhibitory turns the lights off. The cell needs a stronger stimulus or have a stronger desire, to leave the house. Gated channels control where and how signals begin. And here we are done and done. Hope this was helpful. Super excited for you all to view, and hopefully this helps. Thanks. Have a great day.